Why is glass transparent? The explanation of why some substances are opaque and others transparent involves the interaction of materials with light. Scientists tell us that light is energy in the form of electromagnetic waves. Thus light and radio waves are the same kind of phenomenon, differing only in detail, not in principle. In 1860 James Clerk Maxwell proposed the idea that such waves are moving electric and magnetic fields generated by the vibration of an electric charge. This causes an energy message to move out from the vibration in all directions. The wave, he pointed out, would oscillate at a rate equal to the rate of vibration of the electric charge. This, then, is the essential waves. Ultraviolet radiation and infrared radiation all have differing rates or frequencies of oscillation. So all electromagnetic waves are oscillating electric and magnetic fields. What is of importance to transparency is the effect of matter on these fields. All matter is composed of electrically charged particles, so there is almost bound to be some interaction when the electromagnetic waves try to pass through a piece of matter, and in the usual case there is. All of the particles in a solid body are held together in some way or other, molecules attracted to molecules, atoms to atoms, or electrons to nuclei of atoms. And all of these particles oscillate or vibrate back and forth in the solid structure. The stronger the linkage force between particles, the higher the natural frequency of vibration. Some molecules, for example, oscillate at a frequency of about 1018, 1 followed by 13 zeros, oscillations per second. Electrons oscillate about 100 times faster, and nuclear particles oscillate about 100,000 times faster still. If the frequency of the electromagnetic waves striking our piece of matter is the same as the natural frequencies of the body's linked particles, the latter will sway in tune with the waves, much as a piano hums back at you when you sing into the strings. The electrons begin to oscillate in time, absorbing a part of the light energy contained in the electromagnetic wave. When this happens in a material, the electromagnetic light waves cannot get through and the substance turns out to be opaque. But if the frequency of the light waves is appreciably different from the natural frequencies of the linked particles, there is little or no absorption. At most, the radiation is dispersed a little and penetrates right through the substance. Thus, visible light goes through a transparent substance with little absorption because the substance has no constituents that can oscillate at the same frequency as the electromagnetic waves we call light. Glass is not transparent for other frequencies, ultraviolet rays, for example. You cannot get a suntan behind a glass window because glass blocks out the invisible ultraviolet that gives you the tan. Also related to transparency is the matter of color. Visible light is a mixture of electromagnetic waves of frequencies or colors from about 3.9 to 8.4 x 1014 oscillations. It contains all of these frequencies in more or less equal quantities. But many substances can selectively absorb per second. It appears white to the eye only if light of certain specific frequencies. Thus, light of that color is removed from the spectrum and the mixture of the remaining colors no longer appears white. If yellow light is absorbed, for example, the remaining mixture looks violet to us. So we say the substance has a violet color.